Good day. I hope you guys are good. I hope you guys are all well. Welcome to YeboTutor Livestream. Help another day, another dollar. It's a good Saturday. I hope you guys are good. On physics, I think by now everyone has covered momentum. You guys have covered vertical projectile. If you want us to look into those two topics, please drop your comment and leave your comment so that we can also go through like practice questions for those two. But people usually face challenges when they're looking at organic chemistry, which actually for your paper one it contributes almost 50 mark paper two, sorry, it contributes almost 50 marks for your paper two paper, which you'll be writing in June. But in this term as well, you have a control test which will have like more marks as well on the organic chemistry. So let's look into it. So I'm going to start with a small overview on the work so that at least you can be able to understand anytime, any moment. Drop a comment so that we can be able to engage on the comment section, or alternatively you can text in the WhatsApp group, because you have a WhatsApp group. And if you're not in the WhatsApp group, in the description of this video there is a link which directly straight to our WhatsApp channel as well as our WhatsApp group. Do us a favor, do yourself a favor, and make sure that you join so that we can be able to engage and can be able to get assistance anytime you need it. Don't forget to subscribe, because of course, so that you can be notified every time when we are live. Now, when we are looking at organic chemistry, this is a big topic which is very important. So we can see that there is things which are very crucial which we need to understand, which is the classification of the hydrocarbons. And we know that these can be divided into our alkanes, our alkynes. And of course, now we are looking at the term of saturated, where we are saying these are the single carbon bonds only. And when we are looking at the unsaturated, that's when they have two or three bonds which are having, e.g. these alkenes as well as the alkynes. So there is what is crucial, which is understanding the root names and the prefixes, which plays a key role when we are now doing the IUPAC naming. So now we are looking at our root name, our meth, when it's only one carbon atom. It's your meth, 2 eth, prop, 3 but, 4 pent, 5 hex, hept. That's how we need to understand them. Now there to be our methane, that would be the name, the ethane, and so forth. So we need to understand this and understand these molecular formulas. So I did a favor and I was like, okay, let me just combine so that you can see the summary of the homologous series. So when you're looking at our alkanes, this is our number one. Of course, this is our functional group. This is very crucial to understand these specific functional groups which we have. So if we make an example, we said prop is 3. So we can see that they have 3 carbon atoms. So you can see that the longest or the parent chain is 3 carbon atoms. So that's why it's called prop. Then of course we can say that that's propane because they are single bonds, and we know that single bonds are only found in alkenes. No, alkynes, sorry. Then on number 2 we have our alkenes which have double bond, and we know that this, an example again, prop, because there are 3 how many? There are 3 in the parent or the longest chain, and of course we have the double bond there. Then after that we can be able to have an alkenes there. And that's the suffix which we have. Number 3 we have our alkanes which have triple bond. As well, we can make a typical example of alcohols. We'll go deep into them because we have the primary of the secondary as well, so that you need to be able to classify them properly. And we can see that the alcohol, we can see that by this functional group. So in your exams or in your test, you see that they'll give you a diagram already, or the functional group of a specific molecule. So you need to understand, is this an alcohol? Is this an haloalkanes? When you're looking at alkyl halides, sorry, or is it an aldehyde? Is it a ketone? How do we see a ketone? We see through this C, which is double bonded to the oxygen. Also, we can see that we have our aldehydes there. So we need to understand this functional group in order for us to understand all this. And of course, we need to understand this important part, which is the esters, because there is also even a process which is called esterification. So we need to understand those things. So we'll do examples now so that people can understand further. And I'm going to send also this document in the WhatsApp group. So if you're not in the WhatsApp group, you will not enjoy. Then of course we have the chain length and the boiling point and the melting point for the hydrocarbon. So you need to understand these things so that you can be able to explain properly when they are asking you in terms of the melting point and the boiling point of the specific names which you have. Now when you are looking at the bonding in the organic chemistry, we are looking at, okay, we have what we call these different bonds which are formed in the organic molecules, which are called van der Waals forces. So when we're looking at the homologous series, we also have different types of these forces which are acting depending on a specific homologous series. So when you're looking at our alkanes, our alkenes, our alkynes, we have our aldehydes, we have our ketones, our haloalkanes, alcohols as well as the carboxylic acids, we know that they are intermolecular forces acting on these homologous series which we have. And when we are looking at these first three, which is the alkenes as well as alkynes, the most intermolecular forces which will be there, will be the Landers forces. You need to understand that as well. And understand that when we are looking at the aldehydes, ketones, and haloalkanes, there will be London forces as well as the dipole forces. Now, when we are looking at the alcohols, carboxylic acids, now they will now have the London forces. They will also have the dipole forces. Then they'll also have hydrogen bonds, which means they'll need more energy to break through into these alcohols, carboxylic acids, because they have London forces, they have dipole forces, they also have the hydrogen bonds. So when we are looking at these van der Waals forces, we can be able to explain properly in depth in order for us to understand them as well. Now, we have isomers, so we need to understand the definition of isomers. So when I'm looking at our isomers, this means that two or more compounds with the same formula but a different arrangement of atoms. Okay, they have the same formula which they have, but the way they are arranged, it's different. The arrangement of the atoms in the molecules or the structure is totally different, and now thus it will have a different property. So the types of isomers which we have, the first one, we have what we call structural isomers. We can see this is pentane, and it has 5 carbon atoms, 1, 2, 3, 4, 5 in the molecule. But now you can see that this is what 1, 2, 3, 4, 5. Again, we can see that it still has the 5 carbon atoms which it originally had, just like the other one, but the structural formula is not the same as the original one, which is the pentane, but still have the same molecular formula. So we can see that this is a structural isomer as well. This one we have 1, 2, 3, 4, 5. Again, you can see that it's structural isomer because they still have the same molecular formula, but it have different structure. When I'm now looking at the chain isomer, now we are saying that, okay, this is a chain isomer only when it has the same molecular formula, but they have different chains. Okay, so we can see that this is our original butane, but the chains are different, even the way they are aligned properly. You can see that we have 1, 2, 3, and now that will be prop because the longest parent chain, we have 3 there, and that will be 1, 2, 3, and now we have our branch there, which is from that side. So we can see that that will be our chain because they have the same molecular formula, but they have different chains. Now we also have the third one, which is the positional isomers, which are now compounds with the same molecular formula, but they have different positions of the side chain. So we need to highlight this part, that the side chain is different and the substituents or the functional groups of the parent chain. So we can see that, okay, we are having, these are the different positional isomers which we are having. We can see that this is what we are looking at when we are looking at the side chain. We are also seeing where it is. They are in different positions, but they are located in all of the molecules which we are having. Even when we are checking these two again, we can see they both have the double bonds there. Forgive me, guys. Usually I always do maths, so I'm trying to blend in as well and do chemistry as well. Okay, so we can see that that's the position which you can see. So we can see that the position of the chlorine is in the first molecule and as well in the second molecule. They are only differs on the positions of that side chain which they are having. Now again, we can see that this is very crucial to understand that we also have the last part when we are looking at the functional isomers, which is number 4. So we have 4 types of them. We have the first one, which we say that the isomer will be the structural isomer. We have chain isomers. We also have positional isomers. Now we are looking at the final one, which is the functional isomers, which are compounds with the same molecular formula, but different functional groups. E.g., the molecular formula is this for these both molecules, but now they are different functional group. This is a methanoate, but this is an ethanoic acid. It still have the same molecular formula. You can see they both have C. We see of those two, there are 2 C's. We also have 2 C's there. We have 2 oxygens over there, and even the hydrogens which we have, they are both the same. They are all 4 on both sides. But now the problem is they are having the different structures and also therefore having the different functional groups. But still, because they have the same molecular formula, they will be called they will be called functional isomers. Now, there is something which is very crucial and critical in order for you to understand by this time, that you need to be able to get these 2 marks. They will question you, what is the boiling point? Define the boiling point. Then you need to define and say the boiling point is the temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. That's the boiling point. that's the important part. Define it as it is. Don't try to use your English. No. Just use this English as it is. Boiling point is the temperature at which the vapor pressure of a substance equals to the atmospheric pressure. Dango. What is the melting point? Melting point, it is the temperature at which the solid and the liquid phases of a substance are at equilibrium, which means they are in the state of rest. Dango means thank you. Define vapor pressure. It is the pressure exerted by a vapor at equilibrium with its liquid in a closed system. The way you define your definitions gives you those 2 marks because they're looking at specific keywords. So please make sure that when I give you this document in our group, please go over it so that you can be able to understand these definitions, which are very crucial and they play a key role. So we need to understand that the vapor pressure decreases with an increase in the molecular mass of the carbon chain or the number of carbons. Then increasing in the boiling point, it results in the decrease in the vapor pressure. Because if you still remember when we're defining the boiling point, we say that it is the temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. So that is very crucial for you guys to understand. Now, we also know that the vapor pressure will increase from the octane heaviest alkene to the methane, which means you're starting from the highest one, which have the highest carbon atoms, to the one which is having the lowest carbon atoms. Boiling point. So I'll also say this so that you can also understand. These are formal questions where you need to explain properly when you're looking at your carbon chain length and also looking at the molecular mass and how does that affect. And now that's where now we include our van der Waals forces. We are looking at our intermolecular forces, how they play their role when you're looking at organic chemistry. So, for instance, vapor pressure increases with an increase in branching. So if we have a lot of branches of the carbon chain, the vapor pressure increases. It increases with the decrease in the exposed surface area. So if we initially had a pentane which is 5 like this, but now this will be something like this. This is a pentane 1, 2, 3, 4, 5. Then we have 1, 2, 3, 4, 5. You can see now they have decreased in the surface area. So we mean that when the vapor pressure is high, which means it is only high only when this surface area is no longer big. It has decreased from the original one which we have. Okay, that's how we can get the increased in the vapor pressure. So those are the things you need to understand in order for you to be able to elaborate on them and explain on them properly. Now, without wasting much time, I want us to look into proper stuff. I'm going to send you this document so that you can be able to check it out, okay? Now, we have our organic reactions. Very, very crucial. Organic reactions. We are looking at, okay, we have our haloalkane, we have there is a process on how everything is happening. But now what is important is to understand, okay, we have our substitution reactions. So what happens during substitution reaction? We know that compounds with single bonds, and this is definitely your alcohols, your alkanes, or your haloalkanes. If you still remember